Welcome back to another Marcus Maths YouTube video. Today we're going over Unit 2 inside of AP Calculus AB, which is all about differentiation, and Quiz 3, where we are actually going to be covering a lot more of the secondary differentiation stuff. So we're going to see a little bit more complex ideas, including the product rule and the quotient rule. As you can see with these questions, some important formulas that we have to remember with this video, but I'll be writing them out, walking through the process. Make sure to subscribe if you haven't already for both AP Calculus BC and SAT content. Let's go ahead and get started with this one. So as we can see here, we have the derivatives of the two functions, f and h, for when x is equal to -3, and we're trying to find the derivative of f of x over h of x at x is equal to 3. Notice the two functions are dividing, so we're going to use something called the quotient rule. So how we do the quotient rule, we just need to remember the low function is the denominator and the high function is the numerator. So we're just simply going to say low times the derivative of the high function minus high times derivative of the low function divided by low function squared. So how that looks here, when the low function is h of x and the high function is f of x, remember, low function, so we're going to put h of -3 right here. We're just going to replace all the x's with -3, times the derivative of the high function, so f, the derivative of f at -3, and then minus high, so f of 3, derivative of the low function, f of -3, my bad, times derivative of h at -3 over h of -3 to the power of 2. Okay, now that we have all these, we're simply going to substitute them all out. H of -3, we can see that is equal to -5. So we have -5, and our denominator is going to be 25. -5 squared is 25. Times f, the derivative of -3 is equal to 2. So we have -5 times 2 minus f of -3, which is 8, minus, put this in parentheses, 8 times h of -3, which is 5. And now we multiply. We have 40 here. We have -10 here. -10 minus 40 is -50. -50 divided by 25 is -2. So using the quotient rule, low derivative of the high minus high derivative of the low over low squared. Yeah, there's a pretty nice jingle that goes along with the quotient rule. If you search that up, I'm sure you'll find someone who goes over that. But the answer to this one is simply -2. Let's move on to the next question. Okay, we're dealing with some trigonometric functions here and some natural logs. Very simple. All we need to remember is that the derivative of the natural log is going to be 1 over x, while the derivative of sine is going to be cosine. Derivative of cosine is going to be negative sine. So that's pretty important stuff. We're just going to have to memorize a lot of these basic derivative rules. Highly recommend just searching up basic derivative rules, taking note of that, and then just memorizing them, going over them each day, going over quizzes like this each day. So when we're trying to find the derivative of this function, we can simply take it in parts. So we have this first part here, we have this second part here, and then we have the constant. We know the derivative of any constant is 0, so this is going to cancel out. Now we're going to do -4. It's multiplying, it's going to do nothing. So we just take the derivative of sine of x, which is cosine of x. So the first part we're left with -4 cosine of x. Remember, sine of x just changed to cosine of x, because derivative of sine of x is cosine. And then -9, we know the derivative of the natural log is simply 1 over x. So we're left with -9 over x, because -9 times 1 over x is -9 over x. So our f of x, the derivative of f of x is equal to -4 cosine of x minus 9 over x. Okay, on to this next one. We have a function here. We can see it's a quotient of two functions. We're trying to find the derivative of this at x is equal to -1. First, we're going to evaluate the derivative, and then we're going to substitute in our value. So remember, low, so 3x squared times the derivative of the high. The derivative of the numerator is -2 minus the high function, which is that, times derivative of the low function, which is 6x. And then we have that divided by low function squared, which is 9x to the power of 4. Now let's evaluate, let's combine like terms in our numerator, and then we'll substitute in 1. So we get negative 6x squared, and then we need to distribute this right here. So let's first distribute the negative sign to switch this to 2x minus 1, and then we'll distribute the 6x to this. So we can just distribute the 6x to 2x minus 1. We're left with 12x squared plus 12x minus 6, plus 12x squared minus 6x. So plus 12x squared minus 6x. Okay, this goes to 6x squared minus 6x. We can factor out 6x from each term. So we're left with 6x parentheses x minus 1 over our denominator, which is 9x to the power of 4. And if you notice, when we substitute in 1, we're left with 9 in our denominator and 0 in our numerator. So the value is simply 0. Okay, on to this next one. Another derivative that we're trying to find here. But this time our two functions are not dividing with each other, they're multiplying with each other. So this time we're not going to use a quotient rule, we're going to use something different. This is called the product rule. Product rule basically says we can take the derivative of the second function times the first function plus, this time, plus first function times derivative of the second function. So I might have missaid that, but we just need to alternate the derivatives and the times the regular functions. Doesn't matter which order because they're adding with each other. We know that via 4th grade addition properties. So what we can do here, we can take derivative of x to the power 4, which is 4x to the power of 3, ln of x, because we take derivative of 1 and then keep 1 the same, and then we add derivative of the other. So x to the power 4 is going to stay the same here. And then we're going to have 1 over x times 1 over x, because that's the derivative of ln of x. We know that x to the power 4 times 1 over x is simply x to the power 3. And then from here, we can factor out x to the power 3 out of both terms. So we're left with x to the power of 3 out here. And then we have inside of our parentheses 4 ln of x plus 1, which matches answer choice D. So that is a correct answer with this question. Moving on to another product rule. Just going to write this out. Derivative of the first times the second function plus regular first times derivative of the second function. Alright, now let's substitute in all of our values. Just pretend each of these x's has been substituted out for 3. This is 6 times 0 plus 6 times 4. We're left with simply 24 as the correct answer here. Okay, on to this next one. You can probably recognize this by now, but we have a quotient rule here. Notice we might as well just do our denominator. It's cosine squared of x. And then we can start using the rest of our quotient rule. So low, so we're going to do cosine of x times derivative of the high, which is 2x. I'm just going to write this out front. So we have 2x cosine of x, and then minus high, so we have x squared. Then derivative of cosine of x is negative sine of x, so that's going to turn into a plus. Then we're going to have sine of x right here. And as you can notice, we do have indeed a correct answer. That is answer choice B. Sometimes you might have to simplify past this point, but since we have a matching one, we don't need to go any farther from here. Okay, another question here, just off of basic trigonometric derivatives. We know derivative of cosine, once again, is negative sine of x. So we can take derivative of negative 8x, that's negative 8. Then derivative of cosine of x, which is negative sine of x. So derivative of negative cosine of x is going to be negative negative sine of x. Both those negatives cancel out, so we're left with positive sine of x. And we can just rewrite this as negative 8 plus sine of x, or sine of x minus 8. Whichever way is preferable. Okay, last question. We're going to evaluate the derivative of cotangent of x at x is equal to pi over 6. So we can either memorize the cotangent derivative, or let's say we're stuck in a testing situation and we don't know how to figure this out. Well, let's just say for this example, you forgot how to do the cotangent of x derivative. How we would write this, we would express it in terms of sine and cosine. Just remember, cotangent of x is cosine of x over sine of x, so we can rewrite to this. And then notice we're going to have to do quotient rule here, right? We have two functions being divided by each other. We're trying to find the derivative, so we're left with sine squared of x in our denominator, and then we have sine of x, low, d high, times negative sine of x, so we're left with negative sine squared of x, and then we have minus low d high minus high cosine of x. Derivative of the low is just cosine of x, so we're left with minus cosine squared of x. And what we can do here, we can definitely use some trigonometric identities if we wanted to simplify further from here, but we can just simply simplify by directly substituting in pi over 6. If we know our ratios, pi over 6, the sine of pi over 6 simply going to be 1/2, while the cosine of pi over 6 is going to be square root of 3 over 2. So sine squared is negative 1/4, and then cosine squared is 3 over 4. So our numerator is 1 over 4 minus 3 over 4, which is negative 4 over 4, or simply negative 1. And then our denominator, once again, is just 1 over 4. So we have negative 1 divided by 1 over 4. We can rewrite this as keep, change, flip. Well, so first of all, we write this in horizontal notation, and then we can keep, change, flip. So change it to a multiplication sign, multiply by 4. We are left with negative 1 times 4, which is negative 4. So this is one way that we could solve this. Let's say you didn't know how to do cotangent of x, which I'd highly recommend that you just memorize these derivatives for the trigonometric functions. Because the derivative of cotangent of x is negative cosecant squared of x, just like the derivative of tangent of x is positive secant squared of x. So if we just remember this, we can also simplify by substituting in. We know cosecant is the same as 1 over sine of x, so we can rewrite this as 1 over sine squared of x. And if you notice, we're going to get some similar stuff here. Sine squared of x, when we substitute in pi over 6, is 1/4, is 1/2 squared, which is 1/4. The negative 1 over 1/4 is simply equal to negative 4. So C is the correct answer, whichever way we go about it. Showed two ways. Memorization just cuts out that step with quotient rule. But if you want to do actual practice with quotient rule and product rule, simplifying into terms of sine and cosine can indeed be helpful. Now, if you liked this video, you found it helpful, make sure to subscribe to the channel. We're going to be going over the unit test tomorrow for unit 2, so we're going to be going over lots of different types of differentiation, and probably see a lot of the same skills discussed in this video in that one as well. I'll see you guys then. Make sure to like the video, subscribe if you haven't already, and goodbye.